Here we go. Good morning, guys. Welcome back. Week 3, day 3 as well. Today's our last day of classes in this week. So today we're going to see a new topic right before the holidays. Okay, we're going to see just the theoretical part, and we're going to try to comprehend everything that we need from this. Because from this point on, we're starting to see topics that you're going to see in algebra, in algebra 1, algebra 2, pre-calculus, calculus, and so on. Everything that has to do with mathematics is this topic. So this is the main part of math, okay, of the algebra part. So the first definition that we're going to see is monomial. So what is a monomial? Well, a monomial is a real number, a variable, or a product of a real number and variables that have whole number exponents. Remember, we saw already the types of numbers. Okay, we said that the whole numbers were only positives. The integers were the positives and the negatives. Natural numbers were the positives and 0. And the real numbers included everything. Okay, we also said that rational numbers were any decimal, terminating decimal, that will be a rational number. But any rational number will be a non-terminating decimal, okay? So in this case, it is real number. So any number that you, yes, Dana, that you can imagine, like any negative, any positive, any decimal, any fraction as a number itself, that will be a real number. So for example, we have over here 3. It is a constant. Remember, we call it a constant. So the constant 3 is a monomial. The variable x is a monomial. The product between number -3 and x, so -3x, that is a product. I mean, that is a monomial. X to the 4th power, that is a monomial. So a number with a variable that has exponents, that is also a monomial. A number with a variable with exponents with another variable that has another different exponent, that is also a monomial, okay? Now, if we have 3 over x, that is not a monomial, okay? It has to be variables with whole number exponents. Remember that if we make this just to a number that doesn't have a fraction, this number over here is going to become 3 x to the -1. So we don't have it as a rational number. Remember, rational numbers are fractions, okay? So if we don't have it as a rational, then we have a variable that has a negative exponent. Negative exponent is not a whole number. Remember, whole number are only positives. So this is why it's in red. X to the -4, also -4, that is not a monomial. Okay, so monomials are only products. This is a quotient, a division. So that's not a monomial. Okay, only products. Now, polynomial. What is a polynomial? A polynomial is a monomial or the sum or the difference of a monomial. Okay, so sum and addition and difference, the subtraction. So whenever we have additions or subtractions, then we have polynomials. So the last topic, we were seeing variable expressions in order for us to apply all of the exponent laws or the rules of exponents. And I told you, it is only a product. Okay, so in this case, polynomial has additions and subtractions, okay? We call the monomials that make up a polynomial its terms, okay? A polynomial can be named by the number of terms and by its degree. But what is a degree? Well, a degree is the greatest exponent a monomial has, okay? So we can call polynomial either by the amount of terms it has, by the amount of monomials that are added or subtracted, that will be one form, and the other form would be according to the greatest exponent that it has, okay? According to the greatest exponent that it has, then that would be the monomial's name as well. So I have over here an example, a little example. I'm gonna place it over here. So we got 3x to the 4th power y. What would be the degree of this monomial? This is a monomial. So what would be the degree of this monomial? If it's the greatest exponent, what would be the degree? 4, very good. And if I have 5x to the square, y to the 5th power z, what would be the degree for this one? I'm sorry?
The power of 6.
Okay, that was a 5, not a 6, but let's make it a pretty 5 so you can see that it is a 5. There. So what's the degree in there? What's the degree of this monomial? 5. Very good. What if I have the addition? It would be, for example, 3x to the 7th power, y to the 8th power, minus 3x to the 10th power, y. What is the degree of this polynomial? Sorry, can you speak clear?
10.
At 10, yes, because the greatest exponent of them all is 10. So this polynomial has degree 10. But we also said that we can call it not by its degree, but by its amount of terms, the number of terms. So we say if there's a monomial, then it is one term. If it has 2 terms, like in this case, we call it binomial. I have another example in here, x plus 3. If we have 3 terms, we're going to call it trinomial. The example would be 2x squared minus x plus y, okay? That would be the degree, the name according to the amount of terms. If we call it according to the amount of degree, this will be a degree 2. Okay, we're going to go back to that again. And if we have 4 or more terms, then it's going to be called a polynomial only. Okay, so once again, we have polynomials. It's like we have a whole classroom. Okay, all of 7th A would be polynomials. All of you will be called polynomials. Okay, an example. For example, Elisa would be a monomial. Nino would be a binomial. Ana Lucia would be a trinomial. But all of you 3 are also polynomials because all of you 3 are students, but each one of you have a specific name, okay? So 1 term, monomial. 2 terms, binomial. 3 terms, trinomial. More than 3 terms or 4 up, we're just gonna call it polynomial, okay? If you have from 4 up, we're gonna call it polynomial. However, I can say add the polynomial and I just give you this binomial. You need to know that all of them are called polynomials, but some of them have a specific name, okay? Some of them have specific name. And here we have examples. Now, by its degree, the polynomial by its degree can be called linear when its greatest degree is 1. Like in this case, x plus 3, the greatest degree is 1. Or quadratic when the greatest exponent is 2. Remember, we say to the square? Well, that's also called quadratic. Quadratic is to the square. Cubic, the cube would be degree 3, the greatest degree of all the terms. In this case, is 3. And the last one is called to the nth degree. What does it mean? That the degree is n, that any other number above 3 would be nth. Okay, so 7x to the 9 minus 1, this is a binomial of 9th degree. Okay, so you say the number, degree. Okay, so if this was a 20th degree. If it was, I don't know, like a 36th degree. Okay, so you're going to call from 3 up, so from 4 up, the nth degree, because you will have to say whatever number, degree, okay? Just the first 3 have a specific number, linear, quadratic, cubic. Actually, the 4th degree is called quartic, but from there on, we say the nth degree, okay? Are we clear with this part? Yes? These are the types of polynomials that we can name according to their amount of terms and to its degree, okay? And we have some examples in here. So let's copy this little table so we can have and know the degree and the name. So if I say to you guys, write a binomial of degree 2, you need to write a binomial of degree 2. Okay, if I say, for example, write a quadratic trinomial, okay? Let's say that. Let's do that as an example, okay? So we're going to say, write a quadratic trinomial. What are you guys going to do? Well, it says quadratic, so it means that it has to have a degree 2. It says trinomial, so it means, what does it mean, trinomial? It means 3 terms, okay? So you have to have the greatest degree 2. So for example, Javier might say, I want this to be x to the square plus y minus z to the square. We got one term, 2 terms, 3 terms, trinomial. And the greatest exponent is 2. Can it be repeated? Yeah, so I have here the greatest exponent, 2. It doesn't matter if it's repeated, but there's no greater exponent. So it is degree 2. That would be my trinomial, my quadratic trinomial. 3 terms and the greatest degree 2. So everyone can have a different answer. Maybe Valeria Chong wants to say, okay, a degree 2 trinomial. She might say x to the square plus x plus 1. It has 3 terms. X to the square is 1, x is another one, and 1 is the other one. And we have a degree 2, a quadratic trinomial. Okay, so this is a quadratic trinomial. You can have different options of quadratic trinomials, only using 1 variable, using 3 variables, using 2 variables. It doesn't matter because you do have the exponent 2. Are we clear about this? Yes? Okay, so let's place the topic's name. What is today's topic? As usual, the topic's name is inside the definitions. What is the topic's name?
Polynomial.
Polynomials. Very good. And that would be the topic for today. This is the theory. And then in our next class, we're going to start doing something else that would be having to do with procedures, okay? We said, remember, we have additions and subtractions. That is a polynomial. It has to have only additions and subtractions, okay? If not, it will have a different name, which you will be seeing further on. No question, guys?
You can scroll down, please.
Sure, but do you have any questions about this? No questions about the topic? Okay,
No,
this is today's theoretical part of the topic.